Well, good afternoon, everyone, and welcome. I'm Sophie, Development and Program Manager at the Northeast Recycling Council, and I'm excited to welcome you to today's webinar, On-Site Food Waste Management Technologies. This webinar will explore small-scale on-site food waste management technologies, discussing in-vessel composting systems suitable for kitchens, schools, and institutions. The session will cover system options, operational considerations, and the benefit and challenges of managing compost on-site. Attendees will gain practical insights from real-world applications and learn what factors to consider when implementing these systems in their own communities or facilities. Some housekeeping details before we begin, just a few quick notes. This webinar is being recorded. You'll receive a link afterward to the recording copies of this presentation, which will be uploaded to NERC's website. Please feel free to type your questions into the chat box at any time. We'll have a Q&A session at the end of the presentations. A little bit about NERC. We're a nonprofit working to minimize waste and conserve natural resources. We bridge informational gaps across the public and private sectors. And currently we serve the 11 Northeastern states and organizations nationwide. This is the agenda today. We'll start off with the introductions as I am now. We'll move into speaker presentations and then have a facilitated Q&A at the end. Our speakers for today will be Jen Heaton-Jones, John Culpepper, and Rick Watson. I will now pass this over to our moderator, Renee Panetta. Renee Panetta is a waste reduction consultant with CET, primarily focused on the Rethink Food Waste New York program. Renee has been involved in resource management and waste diversion for over 15 years and enjoys collaborating with stakeholders throughout the industry.
Well, thank you very much, Sophie. I'm pleased to introduce our presenters today. Jen Heaton-Jones is the Executive Director for Housatonic Resource Recovery Authority, and then we'll be joined by John Culpepper, who's the Certified Soil Food Web School Microscopist with Compost for Good. And then our final presenter will be Richard P. Watson, the Executive Officer for Delaware Solid Waste Authority. So I invite you to enjoy the presentations, and as Sophie said, at the end we'll have time for Q&A. So Jen, if you'd like to kick us off, that would be great.
All right, great. Thank you. Can you see my screen okay? Great, thank you.
Great.
Good afternoon, everyone. Well, in order to, I'll get right started. So in order to understand the importance of local on-site composting solutions for municipalities, where I will bring in that perspective, particularly for residential food scraps, AKA organics. I do want to start off with how we got here. And so we started in 2013, about 12 years ago. And this is a shot from one of our original programs. And I thought at the time it would be really simple. Collect food scraps from residents at the curb, send it to a local processor. They make compost, and then I would give it away as an incentive to join the program. Well, it sort of worked out that way, but it wasn't that simple. And more importantly, it was actually the barriers and challenges that helped guide us to build our own processing capacity. So we started out in one small community, Bridgewater, Connecticut, with just under 900 households, a population of just over 1,600 people. The residents would bring their scraps, and do bring their scraps, to a local transfer station or a recycling center, and they dump contents into a designated container. And today we've grown to 29 collection sites throughout the region. Residents had complained drop-off locations at our local transfer stations were way too out of the way, the hours are limited, and they're only open about 2 days a week or about 4 hours a day. And so we've begun installing satellite collection containers that are available 24/7. And this is just a quick reference on the satellite collection containers. We're using Metro Store enclosures. They have a 65-gallon wheeled cart tucked inside. They're locked at all times. Residents use a mobile app that unlocks the lid at the top, and then they use a foot pedal to open it. So in the beginning, we were collecting those food scraps at those 9 municipal transfer stations, but spending a great amount of money and time transporting the material to a commercial processor. These brown dots that you see here represent the 3 options for disposal. Within the region, there's 2 commercial composters, and over in the middle of the state, there's Quantum Biopower, our one permitted AD facility. So why build on-site capacity when we have commercial capacity? Well, besides the current concerns that we had on the long-term success of the program due to cost getting the material to any one of them, they were limited. The number of commercial processors are very few in the state. And we experienced inconsistent acceptable list. We found that commercial processors all had a different acceptable list. Some take compostable bags, not others. That was a challenge because depending on the municipality, we used all three processors, but we wanted all the towns to use the same uniform list of acceptable items. And then there's unsustainable transportation cost. We found the cost to transport the material and tip it was unsustainable. Many of the drop-off programs are free for the resident and they don't generate revenue to cover the cost. It also made it difficult to gain that and maintain support from our town administration. And then there's the distance to processors. We have a large geographic area and the transportation to any given processor from a different part of the region was time consuming and costly. And the last is the carbon footprint and T&D, transportation and disposal. It also just didn't make sense. I'm a backyard composter and I had a hard time accepting that we were collecting and transporting this material, increasing our carbon footprint with material that could easily be managed on site at the transfer station. So we set out to build capacity. So the dark green circles represents what we have built and the light green are what we are working on in 2025-26. This is Ridgefield's ASP, Aerated Static Pile Composting System. It was paid for by USDA grant and a Recycle CT Foundation Lee Sawyer grant. This was the first permanent municipal solar-powered ASP system in our region, but also in Connecticut, so we're really proud of that. The goal of this project was to create a self-sustainable, closed-loop composting system for transferring residential food waste into end products for community and agricultural use. This project demonstrated that municipalities can manage food waste locally. We can reduce the carbon footprint of off-site disposal and contribute to the waste diversion goals of the state. And this project also increases access to compost for our residents, for our community garden groups, for our local farmers, for use as alternative to synthetic fertilizers. And it also provides the municipality itself readily available compost for stormwater management and erosion control. So this is our current organics infrastructure in our region, the 29 collection locations, the 2 commercial processors, the 2 municipal ASP composting processing sites at a municipal transfer station, and then the future 2 in-vessel systems to be built this coming year and next year. And I really want to emphasize that if we really want to see residents removing food scraps, organics from their waste at home, we really must build access for easy, convenient disposal, whether it's a drop-off, a pickup, or backyard composting. And in order for municipalities to sustainably manage the material on site, we must take into some other considerations regarding their own resources, like the size of their transfer station and the space available. Can they handle the size of an ASP system that it might take up? The size of a public works department and the employee resources. Do they have enough employees to operate the system? Time it takes to manage the type of system. How many hours a week per employee will it take away from other projects like paving, or do they need a dedicated employee? And then there's maintenance and operational cost. What is that long-term cost to operate and maintain any given system? And the volume of material that needs to be managed, the organics tonnage, what if any, do they have any carbon source? Does the town collect and manage it? And they need to consider, can they meet that 1-to-3 nitrogen carbon ratio? Not all municipalities collect leaves or brush at their transfer station, so it needs to be considered. And I also want to point out that the HRA goal is not only to manage residential food scraps, but to make compost and then give it away. There are multiple processing small scale technologies available for food scraps, and you'll learn about that through NERC. But there are some that are being offered to municipalities that are essentially dehydrators. They don't make compost. They make a byproduct, a product that's a method of waste management, and that's not what we wanted. We want to make compost. So we chose at first to go with an ASP composting system. the aerated static pile. And the mixture of carbon, the leaves, and the nitrogen, the food scraps, are placed on a piping system. The solar panels power a timed blower, which forces air into the perforated piping to circulate the air through the composting pile. The blower can operate either on a grid power or solar power. The system maintains proper moisture and oxygen levels needed to produce the high quality compost that we are really ultimately trying to create. And by inducing the airflow into the compost pile, we're also able to maintain the aerobic conditions without turning the pile, which is what typically happens with a windrow. And that saves a tremendous amount of effort and time. We are pushing air through to optimize the biology of the compost process and to manage the pile temperature. It also helps reduce odors, and it greatly expedites the rate of composting and produces a high quality compost in less time. And this is the basic structure of the system without any material on it. So I just wanted to show without any material, this is as simple as it is. So the pipes have holes. They're set every 4 inches on 2 sides at 4 o'clock and 8 o'clock. Here it shows how the blower is attached to the pipes, and then that air is sent into the pile. And by the way, it's just a bouncy house blower. This is the inside of the shed where the batteries and timers are housed and protected from the elements. And the pile then needs to sit on the pipes for at least 30 days. And then during that time, we track and log the temperatures daily. And then after 30 days, we pull the pipes out with heavy equipment. They will get put aside and then reconnected into the system later. Then we set the pile back on another set of pipes for 14 days. And then after you process the material into compost, it needs to be screened. And so this is our trommel that screens out any large pieces of wood chips or compostable bags that haven't broken down or other contaminants. So when the piles are sitting on the pipes, we add a top layer of finished unscreened compost. This is our biofilter cover. There are several reasons for this layer. First, it serves as an insulating layer so that all the material in the raw mix reach the temperature that's sufficient to destroy the parasites, the pathogens, and the weed seeds. Generally, we want to get it to 131 or more for a minimum of 3 days. And second, equally important to that is that the layer serves as an odor control for biofiltration. And any of the volatile organic compounds or ammonia or greenhouse gases that are wanting to escape off of that raw mix will get absorbed in that 1 foot layer of finished compost, our biofilter, and it will then get treated by the microorganisms that reside in that layer. And then the net result is a very mild, fragrant, and if anyone knows what the smell of compost is, it's just a really nice earthy smell, and it's not offensive to our neighbors. And then the third reason for the layer is a nutrient retention. So it's really important to have it, and it helps with as a barrier for vectors like flies and birds and rodents and larger wildlife. It also helps moisture retention, and it helps improve aesthetics. Other things to consider: use sustainable supplies and material. Our cement blocks that hold down our solar panels are made of Positive, a recycled glass product made by Urban Mining. We are not experts in large-scale composting, although I have learned a lot in this process and in this time in these last few years. We hired a consultant, Jeff Demers from New England Compost, to guide us through the process. He owns and operates one of the commercial facilities in our region. He is also the inspiration behind the AST system. It was what he used at his certified organic composting facility. And this project definitely brought our community together. A local hardware store donated the material for the shed, and a local fence company donated a repurposed fence. So the bay on the right is where the material will sit and cure for that 30 days, and the pile on the left is our ready-to-use material. I want to talk about the benefits of an ASP composting system. It does reduce the cost of T&D, transportation and disposal. We no longer pay as municipalities to have it picked up and tipped. It helps reduce our carbon footprint. Everything stays on site. We resolve the odor issues with that biofilter. We really have no issues with odor because the system uses it, and they are not always used in a traditional windrow composting system. We reduce the cost of processing. There's less labor involved with an ASP compared to like a windrow, less use of equipment, fuel during the active phase of composting than traditional. And we have that readily available compost that can be distributed to the community or used for municipal projects. And I think it's really important as a benefit that residents see the value and understand the entire purpose, because it's right there at the municipal transfer station. And these programs do complement our pay-as-you-throw programs and giving residents real options to reduce their waste. So the challenges, just checking my time. The challenges of an ASP is cost to start. Municipalities often need or want funding grants, permits, local and state. They can take a lot of time, effort, and have some cost. Issues with public works employees. Some towns have limited staff, maybe only a handful, or they're just not interested. They want nothing to do with the compost pile, and they often will use their union status to refuse to work on it. The need for more equipment. There is a need for dedicated equipment, such as a skid steer or the trommel, the screener, blocks. You can certainly get away with sharing equipment as part of different departments, but it's not as convenient. There's the maintenance to maintain the moisture control and the temperature and the proper mix. It is pretty simple, but nonetheless, everything takes time and energy to manage and maintain. And the timer can be put on a remote monitoring system, but that also equals more cost. And then the volume of available inputs, having enough material to mix, depending on the size of the community, it could be challenged to have enough feedstocks. And then there's contamination. It's a challenge from preventing it to managing it. And the screening process does do a good job at removing contaminants, but it is another part of the process that it takes time and energy. And then not listed is there's equipment corrosion to think about. The acidic nature of compost can be corrosive to our equipment. So sometimes you might need to spend more money for more durable equipment like stainless steel or fiberglass reinforced plastic. And so I'm going to also mention real quick the in-vessel composting system that we are moving towards in 2025 and 2026. It's a project to be installed in the town of Kent and Bethel. So the benefits of in-vessel composting is very similar to an ASP. You have the controlled environment, the enclosed system precisely manages the temperature, the moisture, the aeration. It's a little bit more optimized. It also can reduce odor and emissions of a typical pile because it's enclosed. It limits it, and any of the air is actually captured in a hose that's inside. Improves sanitation and pest control because it really is encapsulated, enclosed. It's less potential for rodents and insects and other vectors, and those high temperatures do kill off the pathogens. It's very efficient in space. So it requires a lot less land, and it can be set up in confined areas, making it more suitable for our small transfer stations. The leachate management is really good in these enclosed systems. They're really designed well to capture and recycle the leachate, preventing it from runoff. And then it does make faster and higher quality compost. There are some challenges. The higher cost, it's much more expensive to buy one of these in-vessel systems. It's a much more significant cost of setup and operational cost compared to an ASP system or a windrow system. And then the mechanical requirements, like there's more power that's required as a resource. That can be a challenge, although it can run off of solar, but that also amounts to more cost when you need more solar. So we have produced and given away more than 200 cubic yards of compost since 2022, starting these projects, and we are really proud of the work we are doing. And I look forward to sharing the continued growth of our regional network into the future. So I want to thank you for your time today, and I'll leave you with our fourth grader, Kara from Weston, Connecticut. You put it well, grow a better future and compost. So thank you for your time. And I'm going to stop sharing and hand it off to the next speaker.
Thank you so much for a great presentation, Jen. That was awesome. And we'll bring our questions to you later. Now we'll invite John Culpepper to speak. And John, if you're ready to share, there you go. Thank you.
Okay, can you hear me and can you see my screen?
Yes.
Great, thank you. Thank you all for joining us this afternoon. I am John Culpepper, and I am part of an initiative called Compost for Good. Compost for Good is an initiative. There are three of us, myself, my daughter Katie, and Jennifer Perry, who wears lots of hats. We are a partner of a local not-for-profit called the Adirondack North Country Association. And it looks like, there we go. We work with individuals, businesses, and communities to turn waste into a resource. And while we work primarily in upstate New York, we do work with others around the US and a number of other countries as well. All right, you might have to advance my slides because I have lost control here. There we go. Among a lot of other things, we design open source composting equipment. This is one that I designed with a friend of mine a number of years ago. This is a 4-foot diameter by 20-foot long rotating drum composter capable of processing about 60,000 pounds of food scraps per year. Next slide, please. But that system is, even though it was a DIY system, and if you had the skills, you could build it yourself, I was really interested in designing a much simpler system for backyards and neighborhoods and small organizations. Next slide, please. Okay, so why invent a new system when there are lots on the market already? You can just go ahead and click all 4 of those, I think. Composting, as many of you know, probably, composting in colder climates is a challenge because of the lack of thermal mass, especially in smaller systems. Many of the existing systems are just simply too small, too expensive, or ineffective. Next point, please. So I spent some time wondering if there could be a simpler way to do this. So I stripped out every bell and whistle, and I thought, can I design something that is highly effective, but really super simple? And we think we have done it. This is a schematic design of what we're calling the neighborhood scale composter. Next slide, please. And next, yes, designed to be really inexpensive, and it's made from essentially just highway culverts. Cutoffs can be sourced from a number of places. We often find these for free. Places like engineering firms, construction firms, highway departments often will have dinged up HDPE culverts, and we can often acquire them for very little to free. We've got lots of experience with operating 3-foot diameter and 4-foot diameter units. Next slide, please. So, as I mentioned, drum sourcing can come from a lot of places. Next. And here is a picture of a yard. Next, please. Of a bunch of culverts that are dinged up. We had a project recently where we purchased a brand new 4-foot diameter, 20-foot long drum, and those without taxes is about $2,200 in upstate New York. That particular unit, we ordered 2 of them, and each one was cut into 5 4-foot sections. Next slide, please. So what can be composted in these systems? Next. All food scraps, including meat and dairy. Next. And we've also processed a lot of paper products, paper napkins, things like that, and other organics with caveats. and I'll mention why there are caveats in just a second. Next slide, please. What should not be composted? Next. The compostable flatware and other compostable items simply don't. There's not the residence time at the high enough temperatures for those kinds of things to be broken down. And of course, small bones are easily digested or composted in this system, but larger ones are not. We simply throw the larger ones back in the system or put them out in the woods for the field mice to enjoy. And of course, you don't want to put regular plastics in there. Next slide, please. So when operated correctly, the material in these systems can reach up to 150, 155, sometimes all the way up to 160 degrees. And of course, this is the US EPA's guidance for reaching PFRP. And we also use these in connection with a half-inch portable drill, and care should be taken when operating the drill because they are high torque and they can injure your wrist. Next slide, please. And next. And next. We have a lot of these units that are being operated by a lot of different people. We don't yet have any stories, any confirmation that that dogs, bears are impacting these systems. When operated correctly, the temperatures are such that flies aren't a problem. And from my perspective, I'm really excited about this because this is a scalable system. If you wanted to get into this business of composting, whether you're a school or a small organization, you can start with one or two, and then you can add on as need be. The con for me is this takes, of course, a little physical effort. With all the bells and whistles stripped out, you've got to provide some bells and whistles. Next slide, please. And next. So we were working with a colleague of ours up in Ontario to design this compost auger that fits into a half-inch drill chuck. And that auger then is plunged up and down in the material to both aerate and mix. When fully composted, the drum, since it's smooth bore on the inside, you can simply pick the drum up with a tractor. In the case of a 4-foot diameter, this is 3-foot diameter drum that you're looking at, or it can be tipped over and the material falls out pretty easily. Next, please. Component parts, there's not many. Next. Just the drum, a compost thermometer, compost auger, and can include a cover and a wood base if you want to try to stimulate convective flow inside of the material. Next slide, please. So, and continue. Yeah, we're seeing a lot of people employ these systems, from backyard composters up to organizations. And those who are interested in getting into the business but don't have the outlay of cash to buy a larger in-vessel system or the equipment for a large windrow system. Next slide, please. So the system, whether it's a 3-foot diameter or 4-foot diameter, there are wood chips at the base, and then food scraps and wood chips are combined in a layer cake type method. And before you add new material, we encourage folks to aerate and mix with that specially designed drill. And then when you're done, you add a little bit of either food scraps or material that's already been composted to cover up anything that flies might want to lay eggs in. And then you repeat the process. It's really as simple as that. Next slide, please. So, and continue. This is a case study that we did a couple of years ago for Camp Dudley, located on Lake Champlain. They currently have they run a total of 7 weeks. There's a lot of children down there. I'm not sure how many, but lots and lots. But each summer over the last three, they've composted 27 to 30,000 pounds of food scraps from their cafeteria. And more than happy to uh, send you a case study, or if these slides are made available to you after the presentation, I think you can just click there and get the case study. Next slide, please. And here's Matt, the executive director of Camp Dudley, showing you how he's aerating a 4-foot diameter unit. Next slide, please. And continue. This is our more recent collaborator, Pitney Meadows Community Farm. Continue with the bullets, please. Yeah, and this is a pilot for the town of Saratoga Springs. The composting program is run by interns. I mention this because it is truly something that is so simple that someone without any composting experience, with just a little bit of training over the phone or video, in person, what have you, can learn to operate these systems. By day 4, after first starting this process, they were already up to 150, 155 degrees, and then wrote me a message because they were concerned that they were getting too high of temperatures. So this system, or this setup is capable of composting tens of thousands of pounds of food scraps per year. They have 5 4-foot diameter units. Each 4-foot diameter unit is about a cubic yard of material in there. And so, and the retention time during the primary decomposition is anywhere from 18 days to longer. So every 18 to 20 days, if operated correctly, once they're full, you can dump out the material, move the material, or leave it in place if you'd like, and begin secondary decomposition, and that usually takes 3 to 4 weeks. Next slide, please. And this is they had an artist come and draw some pictures of microbes, I think, on there. And this slide also shows some interpretive signs and some lids that they made. It looks like out of aluminum. Again, some folks operate these with lids, some without lids. Next slide, please. And there is an island on the New York, or the U.S. Canadian border, called Wellesley Island, where they have been operating their neighborhood scale systems for maybe a year and a half now. And they have about 300 full-time residents, more in the summer, and they seem to be very, very happy with their system or with their setup. Next slide, please. And we're working with a colleague of mine over in Burlington, Vermont, and she has employed, I think, 12 to 14 of these systems around the city of Burlington, New York. You can see that they're hauling food scraps by bicycle. They're even transporting the drums by bicycle. Next slide, please. And since this design has been out there on the web for a year or so, I know that they're being set up in other places. I don't always have information about who's taken our design and employing that at their facility. We also do a lot of work at my research facility in Jay, New York, where I do a lot of experimentation with recipe development. Next slide, please. So These systems can be operated in a wide variety of ways. We've had success with also with a variety of feedstocks, including nitrogenous feedstocks, including food scraps, diverted human urine, spent brewery mash, animal bedding, and even animal mortalities to the size of medium-sized dog in a 4-foot unit. And these systems work really well with wood chips, but if you're actively augering every several days, you can use wood shavings, and I've even used a large amount of wood pellets. Those are densified sawdust, typically purchased for pellet stoves and pellet boilers. Next slide, please. And it's even, and if you're not into a portable drill, you can pick up a manual auger right off of Amazon or some other site, and you could aerate the material that way. Next slide, please. And if you're not into augering at all, you can take a water pipe. I think this is a 1/2-inch water pipe that I used, and you can make chimneys in the material, and those chimneys will not collapse if you're careful, and you can make a number of chimneys. And this setup is I've seen work really well when the drum is set on wood pallets with a air plenum underneath, and when the material begins to heat up, convection starts, and can be an effective way to get air into the system. In fact, my colleague in Burlington claims that she's getting higher temperatures in the wintertime using this method than in the summertime. And that I think is a result of the temperature differential between the material in the drum and the outside. So very excited about this. It's very, very easy to operate, very inexpensive, and we're seeing a lot of interest. Next slide, please. And that's my contact information. Sorry for the confusion earlier, and thank you. And I'll stop sharing.
Thank you so much, John, for that great presentation. We very much appreciate it. I see lots and lots of questions rolling in, so I'm looking forward to having our presenters answer that at the end. The next presentation will be by Richard Watson. So, Rich, I invite you to start your presentation.
Okay, thank you. Let's see here. Here we go. Okay, everyone see that?
Sure do.
Okay, great. Hi, I'm Rick Watson, Chief Executive Officer of Delaware Solid Waste Authority. And a little introduction, Delaware Solid Waste Authority was created in 1975 by the state legislature to handle all the solid waste in our great big state of Delaware. And we've been establishing landfills, transfer stations, recycling programs, and over those many years. And so what I've got today is a little bit different. We call it our Biodigester Grant Program. And I'll explain a little bit again about our situation here. So we're responsible, like I said, for all the waste generated in the state. It all comes to DSWA facilities. And we've done a lot of studies, and I've got a couple quoted here. We have an analysis of organics diversion alternatives that was done in 2017, because back then in our solid waste management plan that we had, a 10-year plan from 2010 to 2020, it was obvious that we were landfilling quite a bit of organics. So we wanted to study it to see where the organics were coming from, what they were consisted of, and what things could be done with it rather than landfilling. And again, that was a study that was done, and we were looking at trying to do large-scale solutions so that we could handle the most and divert the most amount of organics. And at the time, it was thought that having a large anaerobic digester centralized in the state would be the way to get most of food waste and other organics to a diversion system. Unfortunately, the conclusion about that was that it was not practical and way too expensive, a lot due to the collection, transportation expenses, and greenhouse gas emissions. So we started with that in our solid waste plan, but recycling in the state of Delaware could be done by private entities. And there was a few private entities that did some large-scale food waste composting operations. And there was one in northern Delaware in an urban area right next to the Port of Wilmington that was in operation in the teens, the 2000 teens, for a few years. They were unsuccessful, unfortunately. They chose a composting system that was handling up to 160,000 tons per year of mostly food waste. And it was coming mostly from out of state. And it unfortunately created a lot of odors in an urban area. And that caused, especially the legislators and the decision makers to decide once that was shut down, that it was going to be really, really extremely difficult to have any large scale food waste composting operation in the state anywhere. So we were forced with that situation, unfortunately, with a private operation not doing well, to see if we could come up with something that would work, and that was maybe not composting. So we decided to promote something on a simple, smaller scale. We had a better chance for success. And so that's what we decided to do with the selection of an on-site biodigester system. And I'll explain a little bit more. So what we were looking for was on-site, and by on-site in our case was on the generator site. So we're looking more at larger scale, not households, but larger scale generators, but something that they could do on site. And this was a biodigester system that would be in a kitchen area. So in that sort of a system, there are several. Food waste is added throughout the day in this digester, and it can process most food items with no grinding or pre-processing. And it goes through an aerobic digestion technology, which also uses microorganisms to break down the food waste into a liquid form. So there's no solids involved, it's really liquid. And then that liquid is discharged to your sewer system, which transports it to a wastewater treatment plant rather than diverting it from landfills. So that was the type of system that we decided we'd like to investigate and support if it made sense. So our first step was to go study it. So we teamed up with the University of Delaware, who did a study in 2019 through 2021. And what you see pictured there is the digester system that I'm talking about. Well, we decided that a small scale bio high-tech digester would be installed, and then have a bench scale digester was also constructed for more study. And then they had a small installation at a local pizza place, Grotto Pizza, and got experience with that small operation. So, and again, that was a fairly long study. As you see, it was a couple of years. So we found that there was a significant reduction of the food waste to landfill. It was able to handle pretty much all the food waste generated by the kitchens at both places, the university and the pizza place. Of course, it reduced the cost of disposal. You were not hauling it to the landfill. The system was really fairly easy to operate. And we also studied the impact it would have on the sewer system and the wastewater treatment plant. Since it was mostly liquid, it didn't cause any problems with backups or things like that. And the wastewater treatment plant, well, quite frankly, the amount of discharge going into the sewer was very small compared to the size of the treatment plant that it was going to. So for our purpose, it wasn't, it was very minimal impact. So the notable benefit, of course, was the greenhouse gas reduction due there was no trucking with its associated air emissions of this byproduct. So then next, so then we decided, okay, it sounds pretty good. Let's try it out on a larger scale. And that's what our Delaware Solid Waste Authority decided to do. We partnered with Keep Delaware Beautiful, which is a subsidiary of Keep America Beautiful. So we provided the funding, and we decided to use that system, the BioHigh-Tech, and then also an Orca biodigester system. Both were supplied by Earth Biotechnologies out of Glenside, Pennsylvania. And the first year, 2023, we awarded a $35,000 grant to Jansen's Market. It's a grocery store in Greenville, Delaware. And then in 2024, we did the same to Christiana Hilton at Newark, Delaware. And then this past year, we put two of them at the Food Bank of Delaware in Newark and at the Food Bank of Delaware in Milford. And so the picture below is kind of shows a typical model there. So starting with the grant recipient, Jansen's Market, we use the BioHigh-Tech Revolution seed model. It can process up to 500 pounds per day of food waste. It's located in a storage room in the back of the store. And this grocery store also has a cafe. And so it had a food preparation area, which had food waste, along with spoiled vegetables that they had in their store. And the sewer discharge went to the Wilmington Wastewater Treatment Plant, which has an anaerobic digester, which produces gas, and they use the gas in their boilers and generators, which produce electricity. So there was that benefit that was achieved out of this. The next one, the Christiana Hilton in Newark, again, use the same BioHigh-Tech Revolution seed model, can process up to 500 pounds per day of food waste. It's located in their kitchen, and they have mostly food preparation and storage waste, also some food scraps from customers, but they don't put bones or meat in it. They because it is a process it in such a short time, within 24 hours, it needs. So again, that sewer discharge is the same thing. It goes to the Wilmington Wastewater Treatment Plant with the anaerobic digester and the benefit of using that gas for their boilers and to produce electricity. So in 2024, they processed 15,650 pounds of food waste. It's still in operation today. They did have a minor odor problem, which was fixed by improving the discharge connection to the sewer. But the unit itself is self-contained. Once you feed it, you close the lid. It really doesn't have odors that emanate from it. And then our most recent grant recipients this year was the Food Bank of Delaware in Newark, Delaware, which is near the University of Delaware. They happen to use the Orca model, and that can process more. It can process up to 800 pounds of food waste per day, and it's located in a warehouse space near the back door of their cafe. And you see one of their people unloading and loading it into the digester. And it's mostly food preparation waste. They have a school that trains people to learn how to prepare food in kitchen areas. And they also end up having some spoiled food that's donated that can go into this digester. And likewise, the same thing. It goes to a wastewater treatment plant that uses an anaerobic digester and producing gas for beneficial use. So this was a recent number that we got from their initiation May of this year through the month of July. They processed 24,200 pounds of food waste, and they operate 5 days a week, and they love it. It really saves them a lot of money from disposal. And then go to the next slide. Okay, the impacts, on-site biodigester benefits. It really cuts food waste to landfills, lowers the disposal costs. There's no trucking. It's not even going to like you're trucking food waste, whether it's uh, to a composting operation somewhere else. It's just handled right, truly on site, and it's simple to operate. It's really amazing. Inside, there's paddles that stir up the material, and they add enzymes, which is supplied by the company. And it's really impressive when you see it in operation. The caution, though, is you have to have staff that are really interested in using it. And that usually we found isn't too much of a problem because they're generating the food waste. Instead of throwing it in a garbage can, they put it into a container here, this machine. So the only difficulty was like in a restaurant situation where you might have a high turnover of kitchen people and you have to keep people trained. So that is a minor concern. And anybody have questions about the system, feel free to give me a call or email me. We're really happy that this is quite a different way to look at food waste. It's just that it's focused really more on urban areas and larger generators that have a fair amount of food waste on site. But it's been successful, and it really, I think, makes sense for certain situations. And thank you for your attention.
Thanks so much, Rick. What a great presentation. I love that the three presentations were so different from one another and such great information. We have lots and lots of questions coming in our Q&A. I'm going to start with the questions that we had received first from three of you, and then we'll go over to our questions from our attendees. So, Jen, if you can take a moment and let us know approximately how many weekly staff hours does it take to operate both the ASP and the in-vessel systems?
Sorry, I double muted myself. About 4 hours a week, I would say on average, some less, some a little bit more. Depends on, so most of our transfer stations have a drop-off location separate from the system, the composting system. So there's a little bit of time of taking the carts from one location to the next location and then just taking the temperature. So like I said, it could be 2 hours one week and 5 hours the next week, but it probably averages out about 4 hours a week per system.
And that's for either of the two systems, for your ASP and your in-vessel systems?
Yes, it only takes a few minutes for the in-vessel to tip the cart into the system.
Perfect, thank you. And with regard to the compostable products, which ones do and don't you take, and how are you finding the successes with the compostable bags?
So we accept compostable bags. Specifically, we allow the bio bags made from, the company is bio bags. And we do not allow any compostable ware at all. And that could be a whole webinar on compostable ware, so I won't get completely into it. But basically, there's a couple reasons. One, they don't always break down to the amount of time that we're looking to process the material. They're not all made alike. They're not all BPI certified. So it's just easier, just like with the mixed recycling stream, to tell residents simply, no, we don't take it, and stick to food scraps. The whole purpose is food scrap management, not compostable ware management.
Perfect, thank you. And then my final question for you is, can you go a little bit into the costs of the ASP and the in-vessel systems that you purchase? Because I've also seen that question coming up in the chat, so maybe we can just highlight that a little bit.
The ASP system itself, if you're just looking at building the solar power, the pipes, the blower, and the timer, we're talking maybe $15,000 to $20,000. No skid steer, no screener, and none of the other bells and whistles. So just to start out, it's that. But altogether, our entire system costs us about $150,000, and that includes the screener and the skid steer and all the other components. In regards to maintenance, and that's for the ASP system, The in vessel itself, just the container, is about $130,000 to $150,000. Does not include the solar that we're buying on the side because we want to be off grid. The maintenance cost, we've had the Ridgefield ASP system running since 2022. We've had minimal maintenance cost. We had to replace the belt on the screener once. It was $825. Other than that, it's pretty much been maintained well enough that we haven't had any additional costs.
So I'm just going to ask a follow-up question on that. Was there a pad needed to put underneath your ASP? And then for your in-vessel, was it a 20 or a 40 foot at that cost?
In-vessel's 20 foot. And no, we do not have a pad under the ASP. It's just a gravel. It's actually an old landfill, so we can't dig into the site. That's why they have those large cement blocks holding the solar panels. We couldn't go under. We had to stay on top. And it's just gravel, no pad where the piles sit on top of the pipes.
Thank you. That's good to know and a cost saver for folks. So thank you for answering those questions. And I'm sure I'm going to come back to you a dozen times or more for the questions from the audience. John, in terms of your product that's coming out of the system, have you tested the compost coming out of it? And one of the questions I saw pop up in the chat had to do with PFAs, PFOAs, and other materials that may end up residually.
Yeah, good question. We have had the material tested through Penn State Lab, and it's comparable to many other commercial compost that I have seen. But I'm also a certified soil microscopist, and we're interested in producing the highest value compost in terms of its microbiota. And I I test a lot of different composts from farms and municipalities and you name it. And the compost coming out of these systems is of the highest quality that I have seen in terms of aerobic microbial mix.
Beautiful. Thank you. So for somebody that's using it for their own use, how often do you want to empty it between batches?
Yeah, that varies wildly, depending upon how much you're putting in. I can tell you this. I have a 4-foot diameter unit that I'm experimenting with in my little research facility. And my wife and I put our food scraps from our house in, along with some other donated food scraps. And we've been operating this 4-foot diameter unit for well over a year, and it is still only 2/3 full. It gets much fuller. We aerate, the material decreases in volume and just continually breaks down. So it's really quite remarkable. I had no idea that one system could work so long. That's through the summer and the winter.
Nice. So going back to something that you'd spoken about midway through your presentation, about the augering, are there ways to make the compost system a little bit more automated as opposed to the manual or electric auger?
Yeah, I think so. I've been doing a lot of thinking about this. It's a very, very simple system, and I hesitate to add any complexity, but I think that one could put a solar panel situated somehow hanging on these units, on these drums, with a controller and some sort of a air manifold inside the system, so that it operates more like an ASP. But I haven't taken that more beyond the thought phase at this point.
Thank you. That's a good answer. So I'm going to move on to Rick. And the first question for you is, what businesses are best suited for the on-site biodigesters?
Yeah, basically institutions that have kitchens that prepare food, because a lot of the prep food waste is amenable to these types of machines. And you want to have a decent quantity of it. Like I said, those smaller models are 500 or 800 pounds per day capacity. So that's pretty substantial. So your grocery stores, large restaurants, hotels, and the food banks. The food bank is amazing how much food waste they generate. And then universities and schools that have kitchens that, especially the ones that prepare waste. But they take both the kitchen prep waste, and if they have cafeterias, front of the house waste too. The only exception is bones. They just don't decompose fast enough so that they can handle everything else. So,
just on a side note, do you have folks that are doing on-site capture for waste for the food scrap to energy with that system?
well, like I said, it goes to the Wilmington wastewater treatment plant, and they have anaerobic digesters, and they'll make methane gas, and they use the methane gas in the boilers on site for a fuel substitute. But they also have engines that generate electricity from that gas, and they're making their use of that energy that way.
Okay, so it's not happening on site; it's strictly going to the wastewater digestion for that. Reference reports that you had in your presentation, are those available for folks to refer to?
Yeah, anything in my presentation, the organics, the analysis, and the statewide solids management plan, just go to DSWA's website, dswa.com. Pretty simple. Those two are there. And then the University of Delaware study that I mentioned, you can request that by me. Just email me at rpw@dswa.com, and I'll get you a copy.
Terrific, thank you. And then would you also be the contact about the equipment, or is there anyone else that you would recommend that folks reach out to on that?
Yeah, for specifics about how the equipment operates and so forth, I would recommend you call Doug Horner, and I got a phone number, 888-855-1925, and his email is dhorner@earthbio.com.
Excellent.
And I would recommend, going to them. And again, earthbio.com supplies several manufacturers of these digesters, and we're really pleased with their technology.
Great. Sounds like they're a great resource for you as well. So I'm going to go back to our chat now and start putting the questions into you all that the attendees have brought up. Jen, I think the first several in the series are for you, and then we will move on to those that are either for everyone else or for the others on the call. What is the volume of food scrap that can be composted on a site of your initial site size, and what is the square footage of that site?
The site itself, both Ridgefield and Newtown ASB systems are on a half acre each. We take up a half acre, and it all depends on how many pipes or how many networks you want to create. You can expand it as large as you want. The piles themselves, you for maximum quality, you don't want to go any longer than about 75 or 80 feet in your pipes. Your pile is going to be about 6 feet wide. You can go as high as 12 feet or a little bit more, depending on the height of basically your bucket loader. However high your bucket loader can go, you can go that height. And so that was the square footage. That was the question, right? Just the square footage it was the acreage and the square footage of each section. So knowing that it's 75 feet by 6 feet and you need a few feet in between, you can use up as many as you want. We are permitted in Ridgefield to take 12 cubic yards a month for food scraps. And we could go further if we wanted to expand. And it really goes to the size of your community.
That makes sense. Thank you. Then the next attendee is asking, how are your ASP piles managed during the winter?
It's managed all year long. We never stop. If this isn't composting 101, but basically with compost, it's the microorganisms that are heating up the pile. And with that air being pushed in, you're giving them everything they need. They need to breathe, they need water to drink, and they need the nutrients of the food waste. And if you have a good mix, ratio 1-3, sometimes we do a 1-2, and you have that air flowing, you're going to compost and your pile's going to get hot. And so we compost all year long. We never stop, even in the winter, and we get to temperature.
Good to know. Which goes to our next attendee question. What do you have to do to account for weather extremes? And I think I would pose that to you, Jen, as well as to John. And they're referring to -10 to around 100.
Our weather doesn't change needing to manage it. People are eating every day. They're bringing our food scraps, no matter if it's a snowy day, a rainy day, or a hot day. And of course, if there's a snow day, our workers aren't there working and the material isn't going to get dumped or managed. But weather doesn't change the fact that it needs to continue to be maintained.
Thanks,
Yeah,
Jen.
same for the neighborhood scale system. I'm in the Adirondacks, and we also have units at 2,200 feet in the Adirondacks, and they'll hit -30 Fahrenheit several times each winter, and we haven't seen any issue with cold temperatures. And of course, the higher the temperature, the better the microbes function.
Perfect. Jen, have you experienced any pushback from the neighboring community? And there was another question I think that tied into as well about the distance between the compost facility and the nearest residence. So I think that those questions can kind of go together.
No pushback ever in the 10 years that I've been working on these projects. And in regards to the distance, some of our towns are very rural. Our transport stations are, completely out of the way. Some are more central, but certainly they're in nearby neighborhoods in some cases. And, if you manage a compost pile, no matter what kind of composting system you have, if you're managing it well, it doesn't smell, there's no pushback, there's no issues.
Being a good neighbor, that's what it's all about. So we have a question about, do you take photos of incoming food waste? And I would put that question to all three of you. Is that something that any of you have as a basic practice?
Sometimes I will.
I do, and I'm happy to share them. I have overwhelming number of photographs of incoming material. We're constantly taking photographs of our projects.
Perfect, John. Thank you. Rick, any additional?
I just have a few because we're not physically at the sites. They're private entities that do have it, but we can get more if we needed them.
Perfect. So we can have attendees reach out if they've got specific questions on your systems. How do you manage the presence of flies, rats, or other non-welcome guests? And I would say that's for Jen and John both.
Again, if you're managing your pile well, we don't have issues with vectors. So it's your compost, your sites aren't your piles, maybe I should say, aren't sitting there with food waste on top, waiting for the seagulls or other vectors to come and eat it. It gets mixed in with your carbon source, and it's not readily available at the top for vectors. And then with the ASP system, you're putting about a foot of finished unscreened compost on top. So you create that barrier, and we just don't have issues with vectors. And also, small animals like rats and raccoons and if they go to dig into the pile and they hit it where it's hot, they're not interested. They're like, whoa, this is hot.
That's fair. John, any additions to that?
No, Jen said it perfectly. If operated well, all compost systems have little trouble with vectors and things of that sort.
Perfect. Contamination issues. One of our attendees wanted to know how that's managed because they didn't see any sorting infrastructure between the generator and the compost pile.
does anyone want, I can take it as well, but
I think that one was
I
directed
skipped
to you.
over.
Yeah.
Okay. I skipped over that part of the presentation only because I was focusing on the technology of the composting. Again, lots of photographs of contamination. It's not as though we don't get it. Very interesting is the experience that I have over the years. We've had curbside programs, which we started out with in Bridgewater, then to drop-off programs. And then we also had received some curbside residential material from a hauler working to see if we could partner with them with our ASP system. So I've seen it all. Interesting enough, our drop-off programs from our residents are very clean. It's very clean material. It's minimally contaminated. It's the curbside material that has the most contamination. And our contamination runs anything from someone put in vitamins that we don't want, or compostable ware, or a knife. But the most common is the stickers, the rubber bands, the twist ties, or the Ziploc bag with parsley still in it. How do we manage it? The material is collected in large containers, either toters or a small dumpster. And then it's brought over to our site, our ASP site. It's put on what we call a pad. It's not a current, it's just a pad, meaning it's a layer of carbon. We then dump the food scraps. You can see the contamination and it does get pulled out, picked out, what we can visually see. It gets mixed onto the pile, and then it mostly gets taken care of at the end when it goes through the screener. So the screener does a really great job in taking out a lot of the stuff that shouldn't be in there, or any of the stuff that hasn't broken down that needs to get put back in the pile, like a bone or compostable bags.
Excellent, thank you. Rick and John, anything to add to that?
No contamination on ours because they're operated by small scale. We have a lot of experience with large scale, and of course, that's not what I'm talking about today. And it's all about education and communication, and that's not just one time. That's continuous. If you're working with a municipality, which we do on a regular basis, there's a lot of just continual education that has to happen.
Agreed.
Yeah, in our case, it's just training the kitchen staff to put the right materials in. And if the wrong material goes into the like bones, they just won't get into liquid form. So you just have to pick it out of the container. It's not that difficult.
Excellent, thank you all. So the question from another attendee, how long does it take from raw material to compost? So I'm going to pose that to each of you because you have different turn times on that. So Rick, do you want to start us out on that one?
Yeah, within 24 hours.
Thank you. John?
Well, it's a hard question to answer because they're all our systems. The people who are operating our neighborhood systems are operating in all sorts of different ways. But if you had all of the material that you could put into a 4-foot diameter composter, batch composter, for example, the residence time in that composter would be about 18 to 20 days. After that, if aerated properly, you've reached 140, 150 degrees for a number of days, and that material is ready to be then moved to a secondary decomposition area. And so the answer to the question is complicated, but 18 to 20 days, I guess.
Good answer. Jen?
I would say similar. I mean, if the question is how long does it take to break down versus how long does it take to get compost, those are two different answers. It doesn't take very long, but a few days or a week for a lot of material to get broken down. Our ASP system runs, you set it for 30 days. The timer goes off every 30 minutes for 15 to 20 seconds. For 30 days, it sits on that pile. You pull those pipes out as I showed in the video. You're going to move that pile to another set of pipes, and it's going to sit for 14 days. That's to make sure that it's gotten to complete temperature and you've killed pathogens. So you can make compost really fast, You also want to make sure that everything inside that mix is broken down, and that if there are pathogens, if there are weed seeds, it's all broken down and it's killed. So it varies. And also remember, like the size of a cantaloupe and the size of an apple are going to break down differently so many days.
Thank you. I'm going to skip ahead to some of the questions at the end, and then I'm going to come back to some of the ones in the middle, just so everybody's got some equal time here. So in Connecticut or New York, was there a measured amount of food waste total that was diverted from solid waste? So John, I think that one was directed most toward you.
I don't even know how to answer that question because, again, we are an initiative. We don't sell anything. We're not a business. We provide these open source designs. Different people operate them in different ways.
Thank you. And which also helps us to answer the backyard composter. Is it patented, or would anyone be able to teach others how to create one of their own? I know that you have wonderful and strong feelings on that, so I'll hop to that question.
Yeah, none of our equipment that I've designed is patented, and I don't intend to. It's all open source, and people can adjust, modify their equipment to meet their needs. And folks can always reach out to me. I spend a lot of my time on calls like this, helping folks get their systems up and running or troubleshoot them if they're having issues. So more than happy to reach out to me if you're interested in this system, or go to our website. There's lots and lots of instructional videos. We've got a YouTube channel with a lot of videos. So, but you can reach out directly to me if you'd like.
Thank you. There are a couple questions that I'm going to leave in the chat because they're more information specific to product. So those are questions that we can get answered after the presentation. The energy requirements of the biodigesters and the impact on electricity bills. Can you address that a little bit, Rick?
I don't have specific numbers, but they're not significant. The most significant expense, I would say, is the enzymes that you need to add to the mix. You add water is added. You have a little bit of heat needed, and the enzymes. And the enzymes, depending on how much food waste you got, you need to talk to the manufacturer, quite frankly.
That is very reasonable. So this kind of goes to what I was asking earlier. What byproduct would be the most resource efficient when collecting food scrap between compost, biogas, animal feed, etc.? I think that each of you will have responses that you'll want to share on that. Is there one that is most resource efficient, or does it depend on the circumstance and the participant?
I'll be happy to take a stab at that. We're primarily interested in soil health, community health, and so we're interested in producing the highest quality aerobic compost possible to put more carbon back into the soils and to repair damaged soils. But and from my perspective, there are really almost no bad composting systems out there. They all have something to offer.
I agree. And I think it's really important. I mean, what is your end? You could have multiple end goals. Our end goal was waste reduction. So the food waste in our solid waste stream is a low-lying fruit, but we also wanted to make compost. I'm not interested in a system that just dehydrates it. So it really depends on what your goal is. Kind of piggyback on the last question about, did you see a change in the waste stream and what was that impact? We have seen significant change in our waste stream per transfer station. I'll use Newtown's example. We've been collecting food scraps at Newtown since 2014. The average tonnage per year was anywhere between 30 to 40 tons of food waste in that period of time. When we implemented a pay-as-you-throw program in complement and residents realized like, wow, I really need to reduce my waste because I'm going to get hit with the cost per bag, we saw a jump of 30 tons in the previous year to 77 tons the following year in food waste. And one of the incentives is giving away compost. So it all goes hand in hand. It's a really important project and a really important outcome when it comes to material management.
Yeah, and then in my case, our goal is to reduce landfilling and the diversion, and that diversion to the most reasonable solution for environmental impact and end use. Like you say, our system found, in our urban setting, that these systems seem to make the most sense, and they're reliable, simple. So again, that was our goal.
Thank you. All good answers and all different solutions, and it isn't a one size fits all for anybody. So Rick, I think this one's for you. Do you do any analysis of methane emissions due to the transport through the sewer system?
Methane emissions from a sewer system as opposed to from trucking?
Yeah.
I don't understand the question.
I'm not sure I understand the question either.
Yeah, the sewer system theoretically doesn't have emissions except that, at the treatment plant. It shouldn't anyway.
Yeah, I wasn't quite sure about that, which is, I figured if I asked you, then maybe we could sort it out.
No, I guess the question should be like, rather than transporting that solid food waste to, say, a landfill, depends on how far away the landfill is, you're saving that greenhouse gas emissions there.
True.
So I don't know. I'm trying to answer the question.
Yeah, I'm not entirely certain on that one, but I think also you had said your annual report is available and online, so I think folks could refer to that as well, right?
Yeah, there's a lot of information in those reports.
Sorry.
Yeah.
The next question was also for you. Is the system still in operation at the grotto?
No, unfortunately, it was actually it was a 13-year-old unit that was just there for a pilot test. So we just abandoned that unit after it was useful life was off. And Grottos was a very small operation, so we wanted to encourage a larger, a grocery store and food bank. We were trying to get more bang for our buck because, as I said, those systems aren't cheap. But again, what we're hopeful is that we don't envision the authority's going to be buying all these for all the businesses in Delaware. We hope that this will prove the point to the systems that it makes economic sense and environmental sense, and that hopefully will encourage the private sector to adapt these sorts of systems.
Thank you. John, this one's for you. This is an observation question regarding your system. These visually remind me of a vermicomposting system. Have you tried burying them to see what worms could do? It might cut down on physical labor needed to turn and improve aesthetics. Any thoughts on that?
Yeah, I'm a big proponent of vermicomposting, but I have not tried how well that would work.
That new experiment for your testing labs there, John.
There you go.
John, how do you weigh incoming materials? Do you have a process for that?
I do, not for these small scale neighborhood scale systems, but typically we weigh with the other research work that we do here at my facility, and we do it with a postal scale, inexpensive postal scale. I think it's $40, and I've had this one out in a unheated shed for 4 years, I think, and it's just done exceptionally well.
Thank you. Another question was, how do you engage the people to leave their food scraps there? So I think that one, it must be for Jen in terms of what types of engagement processes, procedures might you have used to get people invested in it?
Well, we use a lot of social media and rely on our chief elected officials to help get the word out to our residents in each individual community. But also residents want it. They reach out to us and they want to have that resource. And so we have a lot of information on our website. Anyone who wants more information about our programs can go to our website. We have a landing page for each of our towns and the different programs. So the outreach isn't that hard. Social media, websites, town newsletters, etc.
Thank you. And last question, can you share the cost for the digester units and the company that makes them? And then I'll turn it back over to Sophia.
What was that question again? I didn't get all of it.
Can you share the cost for the digester units and the name of the company that makes them?
Yeah. Okay, yeah. Earth Biotechnologies is the company that sells them. And they cost, the units are 500 pounds per day and 800 pounds per day, about $35,000.
Perfect. Thank you so much. So there are a bunch of questions that will still remain in the chat that we'll get to after the presentation is over. And I will turn it back over to Sophie.
Thank you so much. Thank you everybody for joining us today, and thank you to our speakers and moderator for being here. We hope today's webinar has offered valuable perspectives on the future of food waste. A brief survey will pop up after this webinar concludes. We would appreciate if everyone could take a few moments and share your feedback from today. We look forward to seeing you at future NERC webinars and events, and we hope everybody has a great rest of their day. Thank you.
Thank you all.